All right, so this is our pre-quiz. This is scenario 2, energy drinks. So suppose you work for a company that produces and sells energy drinks. The marketing team claims that the latest flavor is a hit with more than 50,000 consumers. So that sounds like a population. It's believed that 60% of those who tried electric lemonade will buy it again. That's probably my HO. You're skeptical and concerned that the actual percentage may be less and decide to test this claim using a random sample who have tried electric lemonade. 97 customers who have tried electric lemonade are randomly selected, asked whether they'd buy it again. You find that 54 of the 97 say they would buy it again. Create a 93% confidence interval to determine the proportion of customers who'd purchase electric lemonade again. So we're going to be producing a confidence interval this time. And we have a sample of size 97, and 54 said that they'd buy it again. And we're looking to determine the proportion of customers who'd purchase it again. So my parameter is let P equal the true population proportion of customers who would purchase the energy drink, in this case, electric lemonade, purchase a second time. A lot of times something new will come out and everybody will purchase it once and then they don't purchase it a second time. So we want to know what our repeat customers are. Well, our formula for a confidence interval is going to be P hat, that's our sample proportion, plus or minus Z star. And then we have to be careful here. It's P hat times 1 minus P hat over N. When we're working with a hypothesis test, it's not P hat, it's P that we're using in the radical. All right. Well, our X, well, how many people said that they said they'd buy it again? Well, 54 out of 97. So 54 out of 97. So this is 54 and this is 97. That's supposed to be a 4. So let's go ahead and figure out what that percentage is. 54 divided by 97, and that gives me 5567 equals 0.5567. And we said we wanted a confidence level of 93%. So that's my C level. So let's go to work on our conditions. Our conditions, well, what did they say? A random sample. That was important. I should have underlined it. So we have a random sample. So my conditions are, first one, random sample. And it's random sample of 97. And that was given. All right. The next thing, we need to know if that's less than 10%. So N equals 97. We're going to go 97, we'll multiply it by 10, and that's 970. And our population was 50,000, so that's less than 50,000. So we're good there. Number 3, NP has to be greater than 10. All right, but in this case is NP hat because that's what's here. All right, when with the hypothesis test, it's NP. With the confidence interval, it's NP hat. Be careful about that. So in this case, it's going to be N, which is 97 times 0.5567. So let's multiply that. 97 times 0.5567. And we're going to find out that that's 54. Equals 54. That's greater than 10. So that takes care of that part. Now I need to do N times 1 minus P hat. That also has to be greater than 10. So once again, it's 97, but this time it's 1 minus 0.5567. So 97 times parenthesis 1 minus 0.5567, close that. And we find out that that's 43. And 43 is greater than 10. So we're good to go on our conditions. So that's a good thing. All right, we need to calculate Z star. So we're going to go ahead and we don't have degrees of freedom. So Z star means I'm going to have to go to an inverse norm. And it's going to go area. And it's going to be 1 minus my confidence level of 0.93 divided by 2, and it's going to be a left. So let's do that. Second vars, inverse norm. Parenthesis 1 minus 0.93, close parenthesis, divided by 2. Mean is 0, standard deviation of 1, and left. We end up getting 1.8119. Always make it positive because we're positive people. So when I plug in, I have 0.5567 plus or minus 1.8119. And this is 0.5567 because that's p hat times 1 minus p hat, 1 minus 0.5567, all over n, and n was 97. So now we're ready to run our interval. So we're going to go stat test 1 proportion Z interval, which is letter A. And we need to put in our values. Our X is 54. Our N was 97. We wanted a confidence level of 93. And we end up getting an interval of 0.4653 to 0.6480. So 0.4653 to 0.6480. Hey, the claim was that it was 60%, and 60% lies in here, so that's good. So in other words, the claim look of 60% looks like that might actually be a real claim, and it's not really lower. Now, it could be as low as 46%, but it could be as high as about 65%. So here we go. What are we? Well, we're 95% or 93% confident. We are 93% confident that the true proportion of customers who would purchase Electric Lemonade a second time who would purchase a second time. So we're 90% confident, 93% confident that the true proportion of customers who would purchase Electric Lemonade a second time lies within the interval 0.4653 to 0.6480. Finally, what is the meaning of that 93%? The meaning is in repeated sampling, we expect to capture. What are we going to capture? The true population proportion of customers who would purchase electric lemonade a second time. Well, how often do we expect to capture it? 93% of the time. And remember, this is our brag. Basically said if we did it over and over again, we would expect to capture the true population proportion 93% of the time. All right. I hope that helped, and I hope to see you on the next one. Thank you.